Quadratic equations can have one, two, or no real solutions. Here are the steps for solving quadratic equation by factorizing. For example, x square minus 2x minus 15 equals 0. Now factorizing left hand side, x plus 3 times x minus 5 equal to 0. This means either x plus 3 equal to 0 or x minus 5 equal to 0. X plus 3 equal to 0 implies x equal to minus 3. And x minus 5 equal to 0 implies x equal to 5. Therefore, x equal to minus 3 and x equal to 5 are the solutions of the equations. Now for x square is equal to 30x. That is 5x square minus 30x equal to 0. Now take 5x as common. 5x times x minus 6 equal to 0. This means either 5x equal to 0 or x minus 6 equal to 0. 5x equal to 0 implies x equal to 0. And x minus 6 equal to 0 implies x equal to 6. And 6 equal to 6 and 0 are two solutions of this equation. Now for x square minus 16x plus 15 equal to 0. Now factorizing left hand side, 2x minus 3 times 2x minus 5 equal to 0. This means either 2x minus 3 equal to 0 or 2x minus 5 equal to 0. Now 2x minus 3 equal to 0 implies x equal to 3 by 2. Then 2x minus 5 equal to 0 implies x equal to 5 by 2. And 6 equal to 3 by 2 and x equal to 5 by 2 are the solutions of the equation. Let's solve quadratic equations by using quadratic formula. The formula is given by x equal to minus b plus or minus root of b square minus 4ac by 2a. For example, 3x square minus 7x minus 1 equal to 0. Here a equal to 3, b equal to minus 7 and c equal to minus 1. Now applying directly the formula, we got x equal to 7 plus or minus root 61 by 6. That's x equal to 2.46 and x equal to minus 0.135 are two solutions. Now solve by using quadratic formula. 11x square plus 2x minus 7 equal to 0. Let's use the formula x equal to minus b plus or minus root of b square minus 4ac by 2a. That's x equal to minus 2 plus or minus root of 2 square minus 4 times 11 times minus 7 by 2 times 11. That's minus 2 plus or minus 2 root 78 by 2 times 11. Now take 2 as common from numerator and after cancellation we got minus 1 plus or minus root 78 by 11 as the final answer. 2x square plus 11x equal to 5 square minus 18. That's 2x square minus 5x square plus 11x plus 18 equal to 0. Now minus 3x square plus 11x plus 18 equal to 0. Now x equal to using quadratic formula minus 11 plus or minus root of 11 square minus 4 times minus 3 times 18 by 2 times minus 3. It's minus 11 plus or minus root of 337 by minus 6. That's 6 equal to minus 11 plus root 337 by minus 6. And minus 11 minus root 337 by minus 6. That's 6 equal to 4.89 and x equal to minus 1.236 are the solutions of the equation. Let x plus 8 the whole square is equal to 100 by taking square roots on both sides. 2x plus 8 is equal to plus or minus 10. That's x equal to plus or minus 10 minus 8 by 2. That's x equal to 10 minus 8 by 2. And minus 10 minus 8 by 2. That's x equal to 1 and x equal to minus 10 are two solutions of the equations. Now completing this square, here the expression is of the form x square plus bx. can convert into square form by rewriting it as x plus b by the whole square minus b by the whole square. For example, square plus 8x, here b is equal to 8 and b by 2 is equal to 4. Therefore, the expression becomes x plus 4 the whole square minus 4 square. That is x plus 4 the whole square minus 16. Now solve by completing the square. X square plus 4x minus 2 equal to 0. Here b equal to 4. B by 2 is equal to, hence the whole expression becomes x plus 2 the whole square minus 2 square minus 2 equal to 0. That's 6 plus 2 the whole square minus 6 equal to 0. Now rearranging x plus 2 the whole square equal to 6. Now taking square roots on both sides, x plus 2 equal to plus or minus root 6. Hence the solution x equal to minus 2 plus or minus root 6. Now consider the expressions of the form x square plus bx plus c. Here by taking a as common from first and second, we can reduce this form into first form. Then follow the same steps as in first form. For example, write 3x square plus 6x plus 1 in the form p times x plus q the whole square plus r. This is of the form second. Now by taking the as common from first and second, we got 3 times x square plus 2x plus 1. Now apply first form for x square plus 2x. That is x plus 1 the whole square minus 1 square. Now the whole expression becomes 3 times x plus 1 the whole square minus 1 square plus 1. It is 3 times x plus 1 the whole square minus 3 times 1 square plus 1. That is 3 times x plus 1 the whole square minus 2. Now comparing this expression with p times x plus the whole square plus 1. We have p equal to 3, q equal to 1 and r equal to minus 2. Now 2x square plus 6x minus 3 equal to 0. This is of the second form. Now by taking 2 as common from first and second, this can be reduced to first form. That is 2 times x square plus 3x minus 3 equal to 0. Now apply the first form for x square plus 3x. That is 6 plus 3 by 2 the whole square minus 3 by 2 square minus 3 equal to 0. Now 2 times 6 plus 3 by 2 the whole square minus 2 times 3 by 2 the whole square minus 3 equal to 0. That is 2 times 6 plus 3 by 2 the whole square minus 15 by 2 equal to 0. Now arranging x plus 3 by 2 the whole square equal to 15 by 4. Now by taking square roots on both sides, x plus 3 by 2 equal to plus or minus root 15 by 2. That's x equal to minus 3 by 2 plus or minus root 15 by 2. Now rearranging minus 1 by 2 times minus 3 plus or minus root 15. Now for x square plus 8x minus 2 equal to 0, take 5 as common from first and second. It's 5 times x square plus 8 by 5x minus 2 equal to 0. Now apply first form for the portion x square plus 8 by 5x. It's x plus 4 by 5 the whole square minus 4 by 5 square minus 2 equal to 0. 5 times x plus 4 by 5 the whole square minus 5 times 4 by 5 the whole square minus 2 equal to 0. That is 5 times x plus 4 by 5 the whole square minus 26 by 5 equal to 0. X plus 4 by 5 the whole square equal to 26 by 25. Now taking square roots on both sides, x plus 4 by 5 equal to plus or minus root 26 by 5. That's x equal to plus or minus root 26 by 5 minus 4 by 5 Now rearranging 1 by 5 times. So minus root 26 minus 4. Now let us discuss functions. Using the functions f of x equal to 5x plus 3, g of x equal to x square minus 2, and h of x equal to root x plus 1, find g of 4 by h of 3. Now let's calculate g of 4. G of 4 equal to 4 square minus 2. That's 14. Now h of 3 is equal to root 3 plus 1 equal to 2. Now g of 4 by h of 3 equal to 14 by 2 are 7. Using the functions f of x equal to 5x plus 3, g of x equal to x square minus 2, h of x equal to root x plus 1, find g of 4 by h of 3. Now let's calculate g of 4. 4 square minus 2 equal to 14. Now h of 3 equal to root 3 plus 1 equal to, then g of 4 by h of 3 equal to 14 by 2 are 7. Now let's find the roots of m of x equal to 2x to the power 2 by 3 plus 2x to the power 1 by 3 minus dot. For further simplification, let us take x to the power 1 by 3 as y. Hence the whole expression becomes m of y is equal to 2y square plus 2y minus dot. For finding the roots of m of y, let us take m of y as 0. Now factorizing the whole expression becomes 5 plus 3 times 2y minus 4 is equal to 0. Now y equal to minus 3 and y is equal to 2 are 2 roots of m of y. Y equal to minus 3 implies x to the power 1 by 3 equal to minus 3. Now taking cubes on both sides. X equal to minus 3 times minus 3 whole to the power 3. That's minus 27. Now y equal to implies x to the power 1 by 3 equal to, again cube, taking cubes on both sides. X equal to 8 and 6 equal to minus 27, x equal to 8 are 2 roots of m of x. The function is mathematical relationships that maps each value of a set of inputs to a single output. Usually a function of x is denoted by f of x. The set of inputs is called domain and the set of outputs is called range. The roots of a function are the values of x for which f of x equal to 0. Next, quadratic term. The graph has curve shape curve parabola. Parabola will have two different shapes according as a is positive or negative. Now in the given graph, point 1 represents the crossing of y-axis. It is obtained by taking x as 0. Now the points 2 represent crossing of x-axis, which is obtained by taking y as 0. Now the point 3 represents turning point. Graph is symmetric about turning point. For finding the turning point, just rewrite the function f of x as a times x plus p the whole square plus q, and the points are given by minus pq. Let's get the graph of y is equal to x square minus 5x plus 4. Here y is positive, therefore graph has this shape. Now by taking x as 0, we got y equal to 4. Therefore 0, 4 is the crossing of y-axis. Now taking y as 0, we got x square minus 5x plus 4 equal to 0. Therefore after simplifying, we got 1, 0 and 4, 0 are the 2 points of crossing of x-axis. Now for finding the turning point, just rewrite the function as a times x plus p the whole square plus q. Now the turning points are given by 5 by 2, minus 9 by 4. Now sketch the graph like this. Now for finding the points where the graph crosses the y-axis, just take x as 0. Let 0, minus 15 are the points of crossing of y-axis. Now crossing of x-axis is given by taking y as 0. X square plus 7x minus 15 equal to 0. Now factorizing and simplifying the left hand side, we got x equal to 3 by 2 and x equal to minus 5 at 2 points. That's the crossing of x-axis is given by 3 by 2, 0 and minus 5, 0. Now for finding the turning points, just rewrite the function as a times x plus b the whole square plus q. 2x square plus 7x minus 15 equal to 2 times x plus 7 by 4 the whole square minus 169 by 8. Turning points are given by minus 7 by 4, minus 169 by 8. Here the steps for sketching of parabola. First mark the crossing of y-axis as 0 minus 15. Now the crossing of x-axis as minus 503 by 20. Mark the turning points as minus 7 by 4, minus 169 by 8. Now draw a smooth curve by freehand. Now let us sketch the parabola. First mark the crossing of y-axis as 0 minus 15. Next mark the crossing of x-axis as minus 5, 0, 3 by 2, 0. Now mark the turning point as minus 7 by 4, minus 169 by 8. Now sketch the parabola by freehand. The shape ആയോ നോക്കടാ. Now let's try to sketch the given function. Let the graph crosses y-axis at 0, 4. Now the crossing of x-axis is given by minus 4, 0, 1 by 2, 0. Now the turning points are given by minus 7 by 4, 81 by 8. Now let us get the parabola. Graph crosses y-axis at 0, 4. Now crossing of y-axis is given by minus 4, 0, 1 by 2, 0. Now the turning points are minus 7 by 4, 81 by 8. Now sketch the parabola by freehand. Now discriminant. For quadratic function, the expression b square minus 4ac called discriminant. We can predict the nature of roots of a quadratic equation by considering the value of b square minus 4ac. If b square minus 4 is greater than 0, then f of x has two distinct real roots. This when a greater than 0, this shape of the parabola, and the curve crosses the y-axis at 2 points. Here also the graph crosses the y-axis at 2 points. Now if b square minus 4 is equal to 0, then f of x has one repeated root. That is, here the graph meets the x-axis at 1 point. Here also the graph crosses the x-axis at 1 point. If b square minus 4 is less than 0, then f of x has no real roots. That's, the graph never crosses the x-axis. Also the graph never crosses x-axis. Now calculate the value of discriminant for g of x equal to x square minus 3x plus 4. That is, b square minus 4ac equal to minus 3 square minus 4 times 2 times 4. That is 9 minus 32 equal to minus 23. Therefore, the equation has no real roots. Now j of x equal to x square minus 8x plus 16. Here b square minus 4ac equal to minus 8 square minus 4 times 1 times 16. That is 64 minus 64 equal to 0. That is, the equation has one repeated root. Now let us find the range of values of k, for which 3x square minus 4x plus k equals 0 has no real solutions. No real solution means b square minus 4ac less than 0. It's minus 4a square minus 4 times 3 times k less than 0. That is 16 minus 12k less than 0. It implies 12k less than 16. Now k greater than 16 by 12. It implies k less greater than 4 by 3.